if I told you that the next great battleground for high-speed internet isn't on Earth, but 238,000 miles away on the moon? It sounds like science fiction. But NASA and global tech giants like Nokia are already racing to build the first 5G network on the lunar surface. Why would we spend millions to get a signal in a place where no one lives? Is it for astronauts to scroll through social media? Or is there a much more high-stakes reason involving global power? Space mining and the future of humanity? Stick around, because we're diving into the secret lunar space race. Welcome to another deep dive into the future of technology. Today, we're talking about the race for lunar 5G. For decades, space communication relied on old-school radio waves. It worked for the Apollo missions, but it was slow and couldn't handle much data. Now, as NASA prepares for the Artemis mission to return humans to the moon, they need something much more powerful. Imagine trying to drive a high-tech robotic rover or stream 4K video of a lunar crater with a 1960s walkie-talkie. It just doesn't work. To build a permanent base, we need the same high-speed, low-latency connection we have on Earth. NASA recently partnered with Nokia to deploy a network in a box on the moon, this compact. Space-hardened for system is the stepping stone to 5. But why 5G specifically? Because 5 isn't just about speed, it's about capacity. On the moon, we will soon have dozens of robots and sensors. 5 allows these machines to coordinate in real time without lagging, which is life or death when you're navigating the dangerous lunar terrain. But there's another layer to this, the competition. This isn't just a science project, it's a geopolitical race. China and the United States are both aiming to establish long-term lunar bases. Whoever controls the communication infrastructure essentially sets the rules. From mining rare minerals to using the moon as a refueling station for Mars, the nation with the best network will have a massive strategic advantage. Did you know that the moon's surface is covered in regolith, a sharp glass like dust that carries a static charge? This dust can interfere with traditional electronics. Building a 5 network that can survive extreme radiation and temperature swings is a massive challenge in the end. The race for Lunar 5 is about more than just a better signal. It's about building the foundation for a multi-planetary civilization. The moon is our test bed. If we can make 5 work there, we can make it work on Mars and eventually beyond. So what do you think? Is a Lunar 5 network a waste of money? Or is it the most important step for our future in space? Let us know your thoughts in the comments. If you found this video fascinating, don't forget to hit the like button and subscribe. Thanks for watching, and we'll see you in the next frontier.